Okay, so can you see my screen now?
Yeah.
Okay, good. All right. So, um, like I said, simultaneous equations have a place in algebra. And I can just briefly explain that before we dive in. Now, all the algebra we've been doing so far, when they tell you solve an equation for X or for A or for B, whatever letter it is, you would notice that there's always one letter in each of them, right? That you
Mm-hmm.
don't usually have more than one letter. So the the whole idea is this: there's a principle in math that says that the number of equations needed to solve um solve for a particular variable will be equal to the number of variables you have. So in other words, what that means is that if you have one variable that is not known, then you will need only one equation to solve it. And then if you want to push it further, if you have two variables that you do not know, then you would need two equations to solve it. Did you get that?
Mm-hmm.
Okay, good. All right, so that's the basic concept. Of course, you can extend it. If you have three variables, you would need three equations. Now, whenever you have anything more than one equation, that is when you have something called a set of simultaneous equations. Now, why the word simultaneous? I'm sure if I ask you what simultaneous means, I'm not too sure what you would say. But do you have an idea of the meaning of the English word simultaneous?
Mm.
What
Mm.
what comes to your mind when you hear that word?
Um, Wait, can you repeat the word?
Okay, just take a look at my screen. I'll
Mm.
underline it there. Maybe the way I'm pronouncing it doesn't make it sound familiar to you. Can you see the one I just underlined?
Mm-hmm.
Good. So have you heard that word before?
Yeah.
Okay, so what comes to your mind when you hear it?
Does it mean like um does it mean like continuous?
No.
Wait. Does it mean um is it mean like occurring?
Occurring. Okay, maybe you're trying to imply the meaning from the context where it's used. So basically, let me see if I can give you an example of how it's used. Um, when you do things side by side, for instance, if you are, let me see if I can give you a real example that's possible. Let's say you are, um, okay, I'm thinking of an example that you will be able to relate to. Okay, so let's say you're riding a bicycle. Okay, you're riding
Mm-hmm.
a bicycle and you are probably talking to someone else at the same time you are riding the bicycle. Okay,
Mm-hmm.
did you notice that you can do both things at the same time?
Yeah.
Possible, right? So,
Mhm.
when two things are being done at the same time, you can comfortably say you are doing them simultaneously. Okay, so simultaneous implies stuff that's being done at the same time. So let's bring that idea to mathematics now. So what do simultaneous equations mean? Simply put, equations are said to be simultaneous if they are true at the same time for the two or more unknown. Okay, so what that means is, for instance, the value of x and the value of y that will make, if you look at my number 1a, the value of x and the value of y that will make 3x plus 2y to be equal to 5 must be the same value of x and y that will make the second equation 2x plus 2y to be equal to 4. Did you get that now?
Mm-hmm.
So that's the whole idea of saying that the two equations must be fully satisfied at the same time. Now, let's quickly solve one so that you see what I mean. Okay.
Mm-hmm.
I got to know really early that mathematics is not really about talking too much, but yeah, I had to do that kind of background. But let's solve it. I'm sure you would understand it better when I solve it. Okay, here goes. So I'm going to take on the first one. Okay, remember I mentioned earlier that we will be using a method called elimination method. Okay, and I'll tell you why you see why it's called elimination method very soon. So I'm going to write those two equations down. The first one says 3x plus 2y equals 5. So
Yes,
I'll
mom,
just
I'm
take
coming.
3x plus 2y. Okay, all right. And then the second one says 2x plus 2y equals 4. Okay, so um, the idea behind this, like I said, is to eliminate one and find the other. And then when we found the other one, we could now use it to find the one that we eliminated. Okay, so when you're eliminating, you need to be sure about something. The first thing that you need to be sure about is the one that you want to eliminate, the number in front of it. Okay, so for instance, can you see that 2 is the coefficient of y on in the first equation?
Mm-hmm.
Okay, so that's the first equation. And if you look at the second equation, okay, you would also see that 2 is the coefficient of y in the second equation. You can see that. Okay. Now, did you notice something? I wasn't particular about the sign. Okay. Whenever the signs are the same, so how do you eliminate them whenever the signs are the same? Simply by subtracting. Okay. So now let's subtract so that you will see what happens there. So uh 3x minus 2x, what do you think that will give you?
X.
Yes, good. Correct. That's x. All right. Now see the whole idea of making sure that the coefficients are the same. 2y minus 2y is 0, isn't it?
Mm-hmm.
So you are now left with your equals to, and 5 minus 4 is what? 1. Okay?
Mm-hmm.
All right. So that's the solution for x. We just found out now that x is 1, equal to 1. Now, the good thing about simultaneous equations is that both of them are the same, are true, not the same. Both of them are true at the same time. So what that means is that I could either substitute x in equation 1 or in equation 2 to find y. It's my choice. Anyone that I choose to use is perfectly okay. So let's pretend we are substituting in equation 1. Okay. So let's substitute in, let me just put it down there, in equation 1. You may not, you wouldn't need to screenshot this. I'll send the note to you on WhatsApp.
Okay.
All right. So I'm substituting in equation 1. That means anywhere I see x, I can put 1. So that's going to simply be 3 times 1, okay,
Mm-hmm.
plus 2y, because we don't know y yet, and all that is equal to 5. Okay, so what do we do next? You can now go ahead and multiply 3 by 1, and you have 3, as you know. You still have 2y plus 2y, and then you have 5 on the right hand side of your equality sign. Of course, all you need to do is to collect like terms, right?
Mm-hmm.
And the 3 will go over here to meet the 5. And once it does that, you'll be left with 2y equals 5 minus 3. Okay? And that should leave you with 2 on the right hand side. And so you have 2y equals 2. And of course, what do you think we should do to find y finally?
I'm not sure.
So just a reminder, anytime you have an unknown, right? In this case, it's y, and you have a number multiplying that unknown. Simply divide both sides by the number that's multiplying the unknown. So in this case, the number that's multiplying y is 2. So you just simply divide both sides by 2. Okay? So when you do that, this is what happens. 2 takes itself out. And coincidentally, you also have 2 on the right hand side. So 2 divided by itself is 1. Did you get that? Hello, Mason, did you get that?
Pardon?
Did you get that?
Yeah.
Okay. So you can see right now that we solved this equation because x, we found out that x is equal to 1. Okay. X equals 1 and y equals 1. All right. Now, you guys are doing graphs there in class. I don't know
Okay.
if they told you guys how a point is represented on the graph, that you have to use parentheses and the value of the x coordinate first, followed by comma, followed by the value of the y coordinate. Have you guys learned this in class? Hello, Mason.
Yeah.
Have you guys learned about coordinates in class?
Mm, Like the ones that you plot.
Yes.
Uh, yeah, I've done them in like year 6 and year 7. I've done them in year 7.
Okay. Okay. So at least you have an idea of how to arrange the points. You put the x coordinates first, followed by the
Mm-hmm.
y coordinates, right? Okay. So this is how our points would look. 1, comma 1. All right, so I want you to just take a look at the steps again. Was there any parts you didn't get that you would like us to go over? Hello, Mason, can you hear me?
Yeah.
Yes, I said, is there any part that you didn't understand that you'd like us to go over?
No, not really.
Okay. All right. Okay. So this was the first one. I'm going to do one that looks slightly different. This one looks like it already had the um, the coefficient already the same for us. So I'm going to do one that looks different because the coefficients are not um, the same. So I'm going to go to number, let's see. Okay, maybe we should do one that has the same coefficient, but instead of subtracting, we'll be adding to eliminate them. Okay, so let's do number 2a. Number 2a is 4x minus y equals 3. Let me change that to, okay. So it says 4x minus y equals 3. And the bottom one says 6x plus y equals 7. Okay, all right. So, sorry, let me make that clear. Okay, all right. So I wanted to take a look at this. Did you notice that the coefficient of y this time is 1 or minus 1? And the coefficient of y in the second one is plus 1. Can you see that? Hello, Mason, are you there? Hello? Mason, can you hear me?
Mm.
Hello? Mason, can you hear me?
Mhm.
Can you still see my screen?
Mhm.
Okay. So I had already started explaining the second one, but I didn't get any response from you. I'll try to explain it again. Please, I'll need you to respond when I um call out to you. I said the coefficient of y is for the first equation is minus 1, and the coefficient of y for the second equation is plus 1. Now, the difference between this number 2a and number 1a is the fact that the sign in front of the coefficient are different. Okay, whereas the signs in 1a were addition plus plus, but here the signs are minus and plus. Okay, so whenever you have that kind of arrangement where the signs are opposites, all you need to do is to add them. Did you get that? Hello, Mason. Can you hear me? Mason, are you there?